Hello, and welcome to my YouTube channel. I will teach you statistics, mathematics, and daily Leetcode questions. Today's daily Leetcode challenge is subsets. It's a medium difficulty level. So basically, the question states that given a nums array, it can be empty or it can have some elements. We have to make all the subsets, basically a power set of this array. So what is a subset? A is a subset of B if it contains some or all elements that are in B. Okay, so for nums 1 2 3, the subset will be empty set. Okay, power set will have empty set. Okay, or it can have 1, or it can have 2, or it can have 3, or it can have 1 or 2, and like that. Okay, so every element in A is a subset. Every subset A have elements which are in B. Okay, so let's look at this intuitively. Okay, let's say there is a subset A. So nums have what length? 3. Okay, so it can have a length maximum of 3, right? Now let's look at this first one. It has only 1 and these two are empty. Okay, the second one, it has only 2 and the third one is empty. And let's take another example where it has 1 and 3. Basically 2 is not taken. Basically 2 is not taken in this, right? So what can you notice about this? Some elements are taken and some are not taken. Some are taken and some are not taken. So like this, let's say if I start with no elements. Okay, let's say at first one I take some element 1 and then I don't take any elements, then we will have this one, right? If I don't take any element here and then take one element 2 here, right, and then not take anything here, then this will be done, right? And if I take 1 here and do not take 2 here and then take 3 here, then this will be done, right? Like that I can make all the subsets, right? So what can we see about this approach? That at every step, what is a step? Step is the let's say index from start to length of array, right? Those will be our steps, right? At every step we have a choice, okay, to either take the element or not take it. Okay, and this will help you in every kind of subset questions like combinations, permutations, subsets 1, subsets 2. Every solution will be done on this basis only. Okay, only a few tweaks in logics will be there. Okay, so at every step we have a choice to either take the element or not take the element. What does it resemble to? Recursion, right? So there are two kinds of solution in this. One is iterative and one is recursive. We know that every recursive solution can be translated into iterative, but it will be just very tough. Okay, in this case it will be easy, not that tough, but yeah, it's not that intuitive also. Okay, so what will be our recursion like? So let's say we start with nothing. Okay, then we have two choices at every index, right? We start from index 1, then 2, then 3, right? Because 3 is the length. So let's start with 1. We either take the element or we do not take it. Then we either take the second element or we do not take it. right? Same like we take the second element or we do not take it. Then we either take the third element or we do not take it. Here we either take the element or we do not take it. Here we either take the element or we do not take it. And here also we either take the element 3 or we do not take it. Right? And this will be our answer. Let's say 1, 2, 3, 1, 2, 2, 3, 1, 3, 1, 2, 3. Right? 1, 2, 3, 4, 5, 6, 7, 8. Right? So how many subsets can be done? 2 to the power n. Right? Because number of steps will be the height of this tree, right? Which is n. Right? The height of this tree will be n, and we know how many number of leaf nodes will be there, 2 to the power n, right? So this will be our length of our power set. Okay, so we can make this recursion tree, so we can make the recursion also. It's not that tough. Okay, you just have to remember one thing: you either take the element or you don't take it. And when do you stop? At the leaf nodes. Our answers were all in the leaf nodes, right? So we take, whenever we reach the leaf node, we take it as the answer. Okay, so I'll give you a pseudo code. It will be very easy. So let's say that if this is our recursion, right? We have an index I and whatever elements we have reached till now. Okay, so if I, which is our index, is equal to length of nums, basically it has reached the end, right? If this is the case, then we know that we are on the leaf node, right? So we will append it to our output, right? Our S is the subset that we have been adding the elements to. Then we call the recursion again in 2 steps, right? We go to the next element, we have our set S, we either take the element or we do not take it, right? And whenever we reach the end, we just return. We don't do anything, we just return, right? And then our answer will be return out, right? This will make all the subsets, right? So this will be our reached leaf nodes. This will be our choice, right? Okay, now we will see the iterative approach. Okay, the recursion was going for O 2 to the power n. Okay, the time complexity for recursion was O 2 to the power n, right? And space complexity was also O 2 to the power n, right? Because we are storing every subset into n because of every element that we are doing this for, right? Okay, for our iterative approach, we have our output as empty, let's say. Okay, so first element is empty, right? Now for each step, for I in nums, for each steps means for every element in that nums, so we will start with 1. Okay, output, we will add it in the output, right, as what? J plus I for j in output. Okay, I'll explain this to you. basically for every element that is already in the output, we will add the new element to it. Okay, let's do a dry run to like understand what it is. So we return output. Looks very easy, right? So let's say we start with empty set. Okay, we have an empty set. Now what is the first element? First step is we add 1, right? So this will become empty set and 1, right? Now for the second, we will have empty set and 1, and we will add 2 to both of them, right? And then like that. Okay, so for 2 we will have empty set element 1, then empty set plus element 2, right? Second step. So original ones will be there, and then we are adding new elements like this, right? So 2 and 1 comma 2, right? Now you understand. Now for the third step, for element 3, we will have empty set element 1, element 2, element 1 comma 2, and then to every of each of them we add 3, right? So empty plus 3 is 3, 1 plus 3, adding 3 to this will be 1 comma 3, right? So you understand like this, 2 comma 3, 1 comma 2 comma 3, right? 1, 2, 3, 4, 5, 6, 7, 8, right? So 2 to the power 3, which are 8 elements, right? 8 subsets. Okay. So this is how the iterative solution will be. Okay. So for I in nums, you can do like this. Basically, this will be already a list, and you add the element like this, right? You can just append also. It's the same thing. As I said, we are going to do recursion. First, let's start with making our output, right? Then we define our recursion as index and our subset S, right? So if we reach the end, right, the leaf node, we return, so we add the subset to our output and then we return. Okay, and then we will just call our recursion function, right? Either we don't take it or we take it, right? Start with empty set and then just return self dot out. Very easy. Yeah, make sure to put it in a list. Okay. Okay, so as for the, you can see that this is not very optimized, right? For the recursive function, it will be not that optimized, but for iterative, it will be better, right? So we start with an empty set. Okay, we have one element which is empty, which will always be there, right? So for j in nums, okay, we do out plus we add that element to our already existing output array, and we say I plus that element for every I in our output. Okay, and then we return our output. So like I showed you, it will add that element to each of the pre-existing arrays, right? I said we are going
もう死んでいる。何？もうあたくびでギゼブ